Now in this paper too, you can see that in this first question, there is a region, triangular region of uniform magnetic field in which magnetic field is pointing outwards in the positive z direction. And there is a conducting loop PQR that is also in form of a equilateral triangle of same height L, and this is placed in XY plane, same plane, with the vertex of both the triangles coinciding at a point P, and this point P is also x is equal to 0. Now this loop, triangular loop, starts to move with the velocity v in the downward direction, and v is constant, and the system is in horizontal plane, and this orientation remains unchanged throughout the motion of this triangle. We have to choose the correct option which represents the variation of electric EMF induced in the loop PQR as a function of x, starting from x is equal to 0. Now I have sequentially drawn these diagrams that initially this triangle was at that point, and now when it would move by some distance in the downward direction, then the area linked with magnetic field would be this one, and this area linked with magnetic field will start to increase, and dA by dt and d phi by dt, which is flux, would be positive. As d phi by dt would be positive, we know that EMF is minus of d phi by dt, which means that EMF would be linearly increasing. Why I am saying that it is linearly increasing? Due to the fact that this triangle is moving with a constant speed in the downward direction, and with this constant speed the rate of change of area would be constant and EMF would be linearly increasing. So this is the case in all the four options, that initially EMF was negative because dA by dt is positive, and it is linearly increasing. Now at some point of time, obviously when the rate of change of area would be maximum, EMF would be maximum, and at some other point of time you can see that initially area is increasing, and till this figure area is increasing, and this is a symmetric star, and all these 6 small triangles are same. So this area is the maximum area linked with the magnetic field, and when A will be maximum, this is A max, then dA by dt will be 0, which means that a point will come when EMF will become 0. Okay, and after that the area will start to decrease, and the dA by dt would be negative, and EMF would become positive. So we can say that this line will cross 0 once, and it will go in the positive direction. So C cannot be the case. Now and this obviously this is non-continuous graph, and dA by dt variation would be continuous, so we can also discard this option. Now we have to find out that when this EMF graph would cross the x-axis. So you can see that when the EMF graph would cross the x-axis, at that moment of time the EMF would be 0, and at that moment of time dA by dt, rate of change of area, would be 0, and area linked with the magnetic field would be maximum. So we just have to find out this maximum area, and at that point we can find out the value of x. So let us see that in this case, when the area is maximum, then this is A, this is A. Let us suppose that this is A. So these small triangles are equilateral, so all of the triangles will be having same side, A. Okay, and we know that this side is 3A. So let us suppose that the side of bigger triangle is A, so A is equal to 3A. And it is also given in the question that this length is root 3, in fact it is L. So L is equal to root 3A by 2. Okay, and L will be equal to 3 root 3 a by 2. I have substituted the value of a here. Okay, so this is L, and this complete area would be the area of two triangles minus, now you can also, we do not have to find out the area, in fact we can find out the value of x. So x would be this one, this is x. So let us suppose that if this is y, then x would be equal to L plus y, and y will be root 3 small a by 2, and small a is 2 L by 3 root 3. So y will be equal to root 3 by 2 into 2 L by 3 root 3. So this is L by 3. So x is equal to L plus L by 3, which is 4 L by 3. Okay, so this is 4 L by 3, which means that the area would be maximum when x is 4 L by 3, and 4 L by 3 is obviously less than 3 L by 2, and therefore this EMF would be 0 at a value of x which is less than 3 L by 2. So the correct option would be option A. Okay, so now we move on the next question. In this question, you can see that there is a particle of mass m, and that particle is moving under the influence of gravitational field of a body of mass capital M. Capital M is very, very greater than m, and this particle is moving in a circular orbit of radius r0, and its time period is t0. It is moving around this mass m. This particle is subjected to a additional central force which has a potential energy of m alpha by r cube, where alpha is the positive constant and r is the distance from the center of the orbit. This particle moves under these two forces. One force is of gravitational force of this mass m, and other one is this central force in the same circular orbit of radius r0. Now the initial time period was t0, and the new time period of its circular motion is t1. So we have to find out t1 square minus t0 square upon t1 square. So we know that initially, as that particle was moving under the influence of the gravity of m mass, therefore we can say that t0 will be 2 pi under root of r0 cube divided by gm. This is the initial time period which we have already derived in gravitation. And in the second part, it is moving under the influence of a force whose potential energy is given by this. So if U is equal to m alpha upon in r cube, then we know that F will be equal to minus du by dr, and F will be equal to minus m alpha, and differentiation of 1 by r cube will be minus 3 r to the power minus 4. So F will be equal to m alpha into 3 divided by r to the power 4. Now this particle is moving under the influence of this force as well as gravity of that mass. So we can say that this total force acting on that particle will be gmm by r square plus 3 r0, this is r0, 3 m alpha by r0 to the power 4. This is the combined gravitational force, and this is equal to m r0 omega square. I'm cancelling m with m, so this is gm by r0 cube plus 3 alpha by r0 to the power 5 is equal to omega square, and let us write it as 4 pi square by t1 square. Okay, so t1 square will be, or you can see that this is the second equation, and we know that 4 pi square by T naught square will be equal to Gm by R naught cube. This is the first equation. This equation is being written from this one. Now what we have to do, we have to find out T1 square minus T naught square upon T1 square. So T1 square minus T naught square upon T1 square will be equal to 1 minus T naught square by T1 square. So this ratio will be 1 minus T naught square by T1 square. So you can see that if we divide 2 by 1, then it would be Gm by R naught cube Gm by, this is Gm by R naught cube, and in fact we have to find out T naught square by T1 square. So we'll be dividing this plus this equation by this equation. So Gm by R naught cube plus 3 alpha by R naught to the power 5. So it will be plus 3 alpha by R naught to the power 5 divided by Gm by R naught cube. So this will be equal to minus of 3 alpha by R naught to the power 5 divided by Gm by R naught cube, and you can see that it would be 3 alpha by R naught square Gm. Now you can see that there is a difference of negative sign. So this negative sign is occurring due to the fact that you know that obviously this force is minus du by dr, and when we have derived the expression of this force, then this force is coming positive, which means that this force is acting away from the center of the particle, which means that if this is m and this is small m, then this force is acting in the outward direction, and Gm by R naught square is acting towards center. So obviously there would be a negative sign here, you can see, and due to that negative sign there would be a positive sign here. So this is negative and this is positive. So the correct answer is 3 alpha by R naught square Gm. This one, A. Now we move on the next question. In this question, you can see that there is a metal target of atomic number 46 and it is being bombarded with a high energy electron beam, and the emission spectrum of X-rays is analyzed from the target. Now the ratio of wavelengths of K alpha line emitted and the cutoff wavelength is R, and this R is initially 2 when Z is 46. Now same electron beam is bombarded on another metal target whose Z is 41. We have to find out the new value of R. Now obviously we know that lambda cutoff will be equal to hc by ev, where v is the accelerating potential of the electron beam. This is hc by ev, and this lambda cutoff does not depends on the metal target. In fact it depends on the energy of electron beams, and as we know that same electron beam is being bombarded on the different metal. Therefore we can say that the energy of these electron beams would remain same in the second case, and therefore the cutoff wavelength would remain same in the second case. So the ratio R is initially 1 and R1 is initially 2 when Z is 46, and we know that lambda characteristic will be H 1 by lambda is R Z minus 1 square into 1 by 1 minus 1 by 4. So we can say that 1 by lambda is proportional to Z minus 1 square. So lambda will be proportional to Z 1 upon Z minus 1 square. So R is the ratio of lambda k alpha upon lambda cutoff, and lambda cutoff will remain same. So we can say that R1 upon R2 will be lambda k alpha upon lambda k alpha 2. R1 is 2, so R2 will be equal to 2 lambda k alpha 2 upon lambda k alpha 1. So 2. Now lambda k alpha 2 will be proportional to, this is 2 into 1 by Z2. Now Z2, you can see that Z2 will be equal to 41, and 41 minus 1 is 40, and Z1 is 46, so this is 45 square. So this will be approximately 2.53. Okay, now we move on the next question. In this question, you can see that there is a stiff insulating metal wire, insulated metal wire, and it is being bent into a form of circular loop, and this is a single wire. You can imagine this wire going like that, and its two ends are touching these two supports. These supports are conducting, and there is a vertical magnetic field acting on the loop. The initially plane of the loop is in vertical plane, and magnetic field is also in vertical direction. Mass of the loop is m, and suddenly a current is passed through this loop like that. So this loop turns by an angle of theta. We have to find out the value of theta. So you can see that when initially this loop, if we draw the side diagram, then M was like that and B was like that. So torque was maximum in this case, and when this loop turned by an angle of theta like that, so let us suppose that this is theta, then this angle between M, this angle is theta and this angle is theta. So this is theta and this is 90 minus theta. So new torque will be MB sine 90 minus theta. So torque will be MB cos theta, and M is I into pi r square and B cos theta. And torque of mg, now if we see mg acting in the downward direction, then we can relate that this angle is theta. So this angle would be theta. So this distance is r, this is r sine theta, r sine theta. So torque of mg will be equal to mg r sine theta, and it would be equal to I pi r square B cos theta. Okay, cancelling r with r, so tan theta will be equal to I pi r B by mg. So the correct answer will be A. Now we move on the next question. In this question, you can see that there is a small electric dipole P0, which is kept on the axis of this spherical shell. The angle of this dipole with this axis is theta, and the moment of inertia of this dipole about its central axis is I. Now we have to, this shell is given a uniformly charged surface, and it has a charge density of sigma on the surface. Now the radius of the shell is r, and this dipole is free to rotate about this vertical axis passing through the center of the dipole, this axis coming out of the plane. Okay, so we have to choose the correct options. See, first option is A, which is the dipole will undergo small oscillations at any finite value of r. This is wrong, because obviously the dipole will oscillate under the influence of electric field, and we know that inside the electric field, inside the shell, electric field is zero. Inside the shell is zero. So for r is less than r, for r less than r, E will be 0 and there will be no oscillation of the dipole. So option A is incorrect, and option B, the dipole will undergo small oscillations at any finite value of r greater than r. This is correct. Now we know that the angular frequency, or we know the time period, is 2 pi under root I by PE. This is the time period of dipole, and omega will be equal to under root PE by I. Okay, and omega will be, now electric field, we know that electric field on the surface of the dipole or outside the shell, E out, is kq by r square, and if we write down k as 1 upon 4 pi epsilon naught r square, and if we multiply and divide by capital R square, then E out will be equal to q by 4 pi r square is sigma. So this is sigma r square by epsilon naught r square. Okay, and in this equation we can substitute the value of E, that P into sigma r square by epsilon naught r square, and the moment of inertia of dipole is I. Now if we see that for r is equal to 2r, if we substitute r is equal to 2r here, then there will be a term 4 in the denominator, which is not given in the option, so C is incorrect. And if we substitute r as 10r, then there will be a term of 100 in the denominator. So the correct answer are B and D. Now we move on to the next question. In this question, you can see that there is a table tennis ball of radius this and mass this. This ball is being slowly pushed down in a swimming pool to a depth of 0.7 meter below the water surface, and then it is released. This ball comes out of the water with a speed of v without getting wet, and this ball rises up to a height of capital H. All the data is given in here. We have to choose the correct option. Now work done in pushing the ball to this depth is 0.077 joule. So we shall draw the diagram, free body diagram of the ball. It is given that it is being slowly pushed, which means that net force acting on the ball is 0. So we know that if we are releasing the ball, then ball is going in the upward direction, therefore buoyancy will be greater than mg, and therefore the external force which we have to apply will be equal to buoyancy minus mg in the downward direction. And work done by us will be F into D. So work done will be F is buoyancy minus mg into D. So work done will be buoyancy will be equal to 4 by 3 pi r cube, and density of water into G minus mg is given straightforward in the question, and D is also given. So if you substitute these values here, you would be getting option A. Now if we neglect the viscous force of water, then the speed with which the ball will come outside the water will be 7 meters per second. Now obviously when you will release this ball from this point, then it would go in the upward direction because buoyancy is greater than mg. So the speed with which this ball will come out will be half mv square, and when this ball will be moving in the upward direction, then net force acting on the ball will be buoyancy minus mg. So work done by this net force, buoyancy minus mg, into same distance d will be equal to half mv square, and this work done is itself given in option A, which is 0.077, which we have already calculated. So we can calculate V from this equation, and it would be 7 meters per second. So option B is also correct. If we neglect the viscous force in water, then height h to which ball will jump out will be 1.4. So we can check that h will be equal to v square by 2g, and v square is 49 and 2g is 20, so it is not 1.4, it is greater than 2, so this is incorrect. And the ratio of magnitude of net force excluding the viscous force to the maximum viscous force is this. So now net force is buoyancy minus mg, we have already written. So let us suppose that this is F1, and maximum viscous force, now viscous force depends on the velocity, so F viscous will be 6 pi neta rv, and v is maximum when this ball is coming out of the water, because from bottom of the water to the surface of the water, this ball is accelerating in the upward direction, therefore its speed would be increasing, and hence we can say that at the surface of the water its speed would be maximum, and maximum speed will create a maximum viscous force. So this is F2. So again, if you can use the value of v as 7 directly, and you can find out the ratio of F1 and F2, so you would be getting the answer as 500/9. So D is also correct. So you can substitute the values. I'm not wasting this time, and let's move on the next question now. In this question, you can see that there is a positive singly ionized atom of mass number this is accelerated by a potential of 192 volt, and that atom enters this rectangular region of magnetic field in which magnetic field is coming out of this plane, and width of this region is W. The value of magnetic field is 0.1 Tesla, and this detector is used to detect the particle. So let us solve this question. So we know that the value of x is obviously, if this particle will enter this field, then it would go like that. So value of x will be equal to 2r, and r is mv by qb. Now mv is momentum, and momentum is under root 2m into kinetic energy, and q is E because each atom is singly ionized, and B is the magnetic field, and there would be 2 also. So x will be equal to 2 under root of 2m. Now m is the mass of this atom, and mass of the atom is its atomic mass number into mass of a nucleon, and this kinetic energy will be EV. So E into V divided by EB. So x will be equal to 2 under root of am into m into V, which is 192, divided by E, and B is outside, and this is V, and there would be a 2 also. Okay, now you can see the value of x for H plus ion. Now you can see that x will be equal to 2 by B, which is 0.1, and under root of 2 into atomic mass number of H plus is 1, and m is 1.6 into 10 raised to power minus 27, and V is 192 divided by 1.6 into 10 raised to power minus 19. So you can see that this x will be equal to 20 under root of 192 into 2, so it would be 384, and multiply by, this is 10 to the power minus 27 plus 10 to the power 19, so it is 10 to the power 8 with a negative sign, and after coming out of the root it would be 10 to the power minus 4. So root of this is 384, and let us find out the root of 384. So root of 384 is 19.6, so x will be 20 into 19.6 into 10 raised to power minus 4, and you can see that if we approximately take it as 20, so 20 into 20 will be 400, and this is 10 to the power minus 4. So the correct value of this would be equal to A, option A, 4 centimeter. And why this value is coming different is due to the fact that I have not assumed that I have assumed that the mass of proton and mass of neutron is equal. So by taking exactly the number of protons and number of neutrons, you can get the exact answer. Okay, and now let us move on the second part, that if the value of x for this atom is 144, so we know if am is 144, then the root of now in this case we have taken am as 1, so if we put 144 here, so 12 will be the root of 144, and 12 into 4 will be 48. So B is also correct. And for detecting the ions with am ranging between 1 and 196, the minimum height of this detector x1 minus x0 should be 55. So let us find out the value of x for 196. So we know that root of 196 is 14. So the value of x for am 196 will be 14 into 4, which is 56, and the value of x for this 1 will be 4, so 56 minus 4 is 52, so C is wrong. And the minimum width of this region for the magnetic field detecting the ions is this. So minimum width should be equal to R at least. So we have already calculated that if am is 196, then the value of x will be 56, and we have to find out x by 2 because x is 2r, so r will be 28, so this is also wrong. So the correct answers are A and B. Now we move on the next question. In this question you can see that we are measuring the dimensions of a cone, and it is measured by an instrument which has a least count of 2 mm. The diameter and height are both measured as 20 centimeter, and we have to find out the maximum percentage error in the volume of the cone. So we know that volume of the cone is 1 by 3 pi r square h, and if we use d instead of r, so r will be equal to d by 2, so it would be 1 by 12 pi d square into h. So delta v by v will be equal to 2 delta d by d plus delta h by h, and we know that we have to consider least count as error. So delta v by v will be equal to 2 times of 2 into 10 raised to power minus 3 divided by diameter is 20, so 20 to 10 raised to power minus 2, plus delta h is 2 into 10 raised to power minus 3 divided by 20 into 10 raised to power minus 2. So you can see that this is 3 into 10 raised to power minus 2. Okay, and we have to find out the percentage error, so we can multiply it with 100. So percentage error in volume will be equal to 3%. So the correct answer is 3%. Now we move on the next question. In this question you can see that there is a ball. Let us draw the scenario. So this is the scenario. There is a ball which is thrown like that with a speed of v0 at an angle theta naught, and there is a stone which is thrown like that with the speed v0 at an angle of theta 1. Okay, the distance between these two is L, and we have to find out that if for these angles are 45, then they will hit each other in time t1, and if these angles are 60 and 30, then they will hit each other in time t2. We have to find out t1 square by t2 square. We know that in the first case, when theta is equal to theta 1 is equal to 45 degree, then obviously their y components would be same, and now this is not v0, in fact this is something else, v. So we have to equate their y components, because they will be at same height from the ground in same time when they will striking each other. So v0 by root 2 will be equal to v by root 2. So v will be equal to v0 in the first case, and the relative velocity of approach, v approach, will be the relative velocity of their x components. So v0 cos 45 plus v0 cos 45, so it would be equal to root 2 v0, and that would be equal to relative distance L by time taken t1. So t1 will be equal to L by root 2 v0. And in the second case, v0, this theta is this angle is theta naught is 60 degree. So if we equate their y components, then v0 sine 60 will be equal to v sine 30. So v will be equal to root 3 v0, and approach velocity is v0 cos 60 plus v cos 30. So v0 cos 60 is v0 by 2 plus v is root 3 v0 into root 3 by 2. So this is 3 by 2 and this is 2 v0, and that is equal to L by their time taken t2. So t2 will be equal to L by 2 v0. So you can see that t2 is equal to t1 by root 2, and t1 square upon t2 square will be equal to 2. So the correct answer is 2. Now we move on the next question. In this question, you can see that there is a charge which is kept at the center of this cylindrical region, and these two edges subtend this half angle theta on the charge. When theta is 30, the flux through the curved surface is phi, and when theta is 30, then the 60, then the curved surface flux is phi by root n. We have to find out the value of root n. Now we know that the total flux of this cylinder will be flux of curved surface plus twice of flux of disc, these two discs, this and this, and total flux is q by epsilon naught, and flux of curved surface plus twice of flux of disc. Now we can find out the flux of disc, and in fact we have already created this formula of using solid angle. So it is q by 2 epsilon naught into 1 minus cos theta. So this is q by 2 epsilon naught into 1 minus cos theta. So phi of curved surface will be equal to q by epsilon naught cos theta. So when theta is 30 degree, flux is phi will be q by epsilon naught cos 30 is root 3 by 2, and when theta is 60 degree, it is q by epsilon naught into cos 60 is 1 by 2. So you can see that phi dash is phi by root 3, and therefore n will be equal to 3. So the correct answer is 3. Now we move on the next question. In this question, you can see that there are two equilateral triangular prisms P1 and P2, and they are kept in such a way such that their sides are parallel to each other. They are kept in vacuum, and a light ray enters this prism P1 at an angle of incidence of theta, and it goes in the condition of minimum deviation through this prism P2, and the refractive index of these two prisms is root 3 by 2 and root 3, and theta is equal to sine inverse root 3 by 2 sine pi by beta. We have to find out the value of beta. So first of all, let us see that in the case of minimum deviation, this ray will go parallel to the base, and this angle, this is equilateral triangle, so this is 60, this is 60, and this is 60, so this is 30. So if the angle of emergence through the second prism, let us see that angle of emergence through the second prism is E. So the angle at which the ray will emerge out of the second prism will be the same angle at which ray will be entering the second prism. Okay, so this is E. Let us suppose that this is E. So we can find out E by using Snell's law here. So 1 sine E will be equal to root 3 sine 30. Sine 30 is 1 by 2, so E is equal to 60 degree. Okay, now E is 60, and we can also use the Snell's law to find R2. R2 is this angle. So root 3 by root 2 sine R2 will be equal to 1 sine 60, and sine R2 will be equal to 1 by root 2. So R2 is 45 degree. Now we know that R1 plus R2 is A, and A is 60 degree, so R1 is 15 degree, and 15 degree R1 is pi by 12. Okay, 15 degrees pi by 12. So if we apply the Snell's law at this position, then we can say sine theta will be equal to root 3 by root 2 into sine pi by 12. So the value of beta will be equal to 12. So beta is 12. Now we move on the next question. In this question, you can see that there is an infinitely long thin wire, and this wire has uniform charge density of 5 nanocoulomb per meter. This is passing through this spherical shell which has a constant charge distribution which is static, which means that we do not have to take any induction effects on the charge distribution, and we have to assume that charge is being uniformly distributed. The magnitude of potential difference between these 2 points P and R will be. Now this is quite easy question. We know that delta V1 is the potential difference due to this shell only. So this delta V1 will be KQ by now this is the inner point, and we know that at inner point potential is KQ by capital R, where R is the radius, and minus on the outer point it is KQ by 2. So delta V1 is the potential difference between P and R due to shell only, and this is KQ by 2. And delta V2 is the potential difference between P and R due to this wire, and we know that due to wire it is 2k lambda ln RB by RA. RB is 2, RA is 1 by 2. So this is 4k lambda ln 2. Okay, so the total potential difference will be delta V1 plus delta V2, and if you find out the value of delta V1, then it would be around, now let us check the value. KQ, K is 9 into 10 raised to power 9, now 9 into 10 raised to power 9, and Q is 10 nano, so 10 to the power minus 8 and divided by 2. So this is 45 volts, 45 volts, plus if you find out this value, then it would be 126 volts. So this 126 plus 45 will be equal to 171 volts. So the correct answer is 171. Now we move on the next question. In this question, you can see that there is a spherical soap bubble, and inside that bubble is inside a chamber in which initial pressure was P naught, which is 10 to the power 5 pascals. At a certain radius of bubble, the excess pressure inside that bubble is 144 pascals. And now the pressure inside that chamber and outside that bubble is reduced to 8 P naught by 27. So that bubble radius and its excess pressure changes. In this process, all the temperatures remains unchanged, and assuming that air is an ideal gas, then we have to find out the excess pressure in the second case, considering the fact that excess pressure in both the cases is very less than the pressure of chamber. So we know that this process is isothermal, so P1 V1 will be equal to P2 V2, and P1 is the pressure inside the bubble, and we have to neglect the excess pressure in front of the chamber pressure. So we can directly assume that the pressure inside the bubble is chamber pressure. So it is P naught into volume is 4 by 3 pi r cube, and this P2 is 8 by 27 P naught, and volume is 4 by 3 pi r dash cube. So r dash will be equal to 27 by 8 r, and this power 1 by 3. So r dash will be equal to, this is 3r by 2. Okay, so obviously we know that excess pressure delta P is 2T by or 4T by R inside the bubble. So delta P1 upon delta P2 will be equal to R2 by R1, and R2 by R1 is 3 by 2. So delta P1 is 144. So delta P2 will be equal to 2 by 3 of 144. So this would be 96 pascals. This is delta P2. So the correct answer is 96. Now we move on the next question. In this question, you can see that in a Young's double slit experiment, there are two slits A and B, and these slits are oscillating about y-axis, in fact in y-axis, and their mean separation is 0.8, average separation, which is D. The distance between the slits at time t is given by D is equal to 0.8 plus 0.04 sin omega t mm, where omega is 0.08 radians per second, and this distance of screen from the slits is 1 meter. The wavelength which is used to illuminate these slits is 6000 angstroms, and interference pattern changes with time, and central bright fringe remains at origin O. Now 8th bright fringe above O oscillates with the time between two extreme positions, and the separation between these two extreme positions is needed to be calculated. So we know that for 8th bright fringe, we know that delta x is n lambda, so that is n lambda d by d. So y 8th will be, n will be 8, lambda is lambda, and capital D is capital D, and small d is 0.8 plus 0.04 sin omega t. Okay, so we know that y max, which is the maximum height of the 8th bright fringe from O, will be at the time when denominator would be minimum. So sin omega t is minimum when in fact it has a minimum value of -1. So y max is 8 lambda d by 0.8 minus 0.04, while y minimum is 8 lambda d by 0.8 plus 0.04. These are the two extreme positions of 8th bright fringe. So if we have to find out the separation between these two positions, then it would be 8 lambda d, and y max will be 1 upon 0.76 minus this is 1 upon 0.84. So if you will substitute the values, then the delta y will be around in micrometers. Obviously it would be around it would be ranging in fact between 600 to 603. So approximately you could be saying that delta y could be 602. So we can say that answer is 602. Now we move on the next question. Now in this second part of this question, we have to find out the maximum speed with which earth bright fringe will move. We know that we have already calculated in question number 14, previous question, that the maximum separation between two extreme positions, which is twice of amplitude, was 600 micrometer. Therefore A is 300 micrometer, and we know that V max is A omega. So V max will be A, and A will be 300 into omega is 0.08. So it would be equal to 24 micrometer per second. So the correct answer is 24. Now we move on the next question. In this question, you can see that there are two particles 1 and 2, each of mass m, and they are initially connected with a massless spring, and they are on a horizontal frictionless plane. Initially these two particles have their center of mass at x0, and they are oscillating with an amplitude of a and with an angular velocity of omega. Now their positions as a function of time are given by this x0 plus d plus a sin omega t and x0 minus d minus a sin omega t. According to this equation, if we analyze these equations, we can see that d is this distance from center of mass. Okay, and particle 3 of same mass m is moving towards this system with a speed of u0, which is a omega by 2. This particle undergoes an instantaneous elastic collision with this particle 2 at time t0, and finally these 1 and 2 acquires a center of mass speed vcm and oscillates with an amplitude b with same angular velocity omega. If this collision occurs at t is equal to 0, we have to find out vcom upon a omega. Now I think this is a simple question. We can find out the value of v1. v1 is the velocity of the first one, and it is dx1 by dt. So if we differentiate the equation, then we can see that it would be a omega cos omega t, and v2 will be dx2 by dt, and that would be minus a omega cos omega t. Okay, this is v1 and v2, and at t is equal to 0, v1 will be equal to a omega and v2 will be equal to minus a omega. Okay, now we know that ball 3 and ball 2 collided elastically and their mass is same, so we can say that their speed would be interchanged, and we can therefore say that if initially ball 2 was going in the backward direction with a omega and ball 1 was going in the forward direction with a omega by 2, then after collision their speed would be interchanged, and 2 will be moving in the forward direction with a omega by 2, and that 1 will be moving with the same speed a omega. So VCOM, we can say, will be m1 v1, which is m a omega plus m a omega by 2 divided by the total mass, which is 2m. So you can see that this is 3 by 4 m 3 by 4 a omega. and VCOM upon A omega will be 0.75, 3 by 4. So the correct answer of this question is 0.75. Now we move on the next question. Now in this question you can see that in B part we have to find out the amplitude if the collision occurred at t is equal to pi by 2 omega. So in this part it is simple that first of all we know that at t is equal to pi by 2 omega you can see that x, in fact v1 was a omega cos omega t, so v1 is 0, and v2 is minus a omega cos omega t, so v2 is also 0, which means that they are at their extreme positions and their amplitude is a, so we know that they are at extreme positions. And let us find out the velocity of center of mass at this instant after collision. So after collision, we before collision we know that v2 is 0, v1 is 0, and this ball is coming with a velocity of a omega by 2 towards the second ball, and as their mass is same, then their velocities would be interchanged. Therefore after collision the velocity of ball 2 will become a omega by 2 and velocity of ball 1 will be 0, and VCOM, center of mass velocity, would be m a omega by 2 plus 0 by 2m, which is VCOM will be a omega by 4. Now let us draw another diagram in COM frame, center of mass frame. So in center of mass frame we can see that center of mass would be at rest, and this would be the natural length of the spring, which is I think 2d, and this would be the amplitude, and they both would be at their extreme positions. And at this instant of time the velocity of this ball with respect to center of mass, you can see that with respect to ground the velocity of this ball just after the collision was a omega by 2 and VCOM is a omega by 4. Therefore in COM frame velocity of this ball with respect to COM, v2 with respect to COM will be equal to a omega by 4, and velocity of this ball was 0 with respect to ground, and COM has a velocity of a omega by 4 in the forward direction. Therefore its velocity in COM frame v1 COM would be equal to minus a omega by 4, and this minus is representing the fact that this ball would be moving in the backward direction. So let us use positive sign, and we have already used this backward arrow. Okay, now in this case we know that after collision the amplitude is b and it is not a, and we know that there is a formula of velocity v, which is omega under root a square minus x square. V of any one of mass is a omega by 4 and omega will remain same. A is the new amplitude, which is b square, and x is their position from equilibrium. So equilibrium position is this one, x naught, and x naught because we are using in center of mass frame, so this would be the mean position. So the displacement of this ball from the mean position would be a, so this is a square. So cancelling this with this, a square by 16 is equal to b square plus a square. Now b square will be equal to 17 a square by 16. Now we have to find out 4b square by a square, so it would be 17 by 4, and it would be approximately 4.25 around. So the correct answer would be 4.25. Okay, so this was the complete solution of JEE Advanced, and I'll be bringing more videos later on. Thank you.